This is the study location where we have just concluded this our structure modeling and geomechanical modeling study. This located in the complex compressional tectonic zone of Pakistan, where most of the reservoirs are producing eosine carbonates, which totally depends on the fracture porosity, which is secondary porosity. So we have conducted the study in this area for two purposes. One, for the dry hole analysis, which we have drilled in this area, and secondly, for the identification of sweet spots in this complex compressional tectonic zone of Pakistan. Why this is the objective and data sets, why we have started this study. I have already mentioned that we have started for the dry hole analysis and for the identification of sweet spots. These fracture corridors through a different methodology. Normally, we identify the fracture corridors through e-logs, core analysis, and outcrops. But this methodology is somewhat different from the ones which I have mentioned. So the basic is an alternate methodology, geomechanical modeling for the fracture corridor identification and complex compressional tectonic zone of Pakistan. And how we have done through structure modeling and geomechanical modeling approach. And what we have got from this study, we have got the fracture corridor and their characteristics, mainly density and orientation of the fractures in the area. The data set which we have utilized in this study is the seismic data, 3D seismic data and its interpretation, and the well data, well logs, well tops in this area, and mechanical properties of the rocks under study. This is the generalized illustration of my methodology which we have applied in this study in this complex compressional tectonic zone. First of all, we interpret the seismic section, then we validate in QC this interpretation through restoration, balancing, and validation, and finally we build up a 3D structure model of this complex compressional tectonic zone. And this complex compressional tectonic zone model was converted into geomechanical model by incorporating the geomechanical properties of rock and total regional strain in that area from the regional tectonics overview of the area. And finally, we get the characteristics of fractures, density and orientation, and we compare these values with the FMI logs to confirm our study or validate our study. This is the general structure model of our area, in which you can see that there is a basal thrust, and this reservoir is just roll over along this basal thrust, and it is dissected by a number of thrust and back thrust in that area. And we have then applied on every, during these structure model building, we have on every fifth or sixth lines, we have done the structure restoration, validation, and balancing. And we confirm this balancing through this red fall plane. You can see that's the horizon polygon just running through this fall plane. And its validation is that the maximum displacement is in the center of the fall plane, while this just displacement tip outs toward the end of the fall planes.